Okay, it's time to talk about the solution to H4 I mean. H4 gives us the graph of a function made up of line segments, which makes us suspicious that maybe we might have to use some geometry formulas to find the areas. I've got a marked up version here, and we'll talk about those regions I've colored in later. So what happens a lot of times is they give us the graph of f, and then they ask us questions about the graph of g. What's different about this one is in lots of questions, g is simply the area function of f. G would be just equal to this part right here. But in this case, they made it a little bit more complicated. So this is not, in fact, the graph of g prime of x. G prime of x is related to this graph, but it's not exactly that. Notice, again, if g of x were just equal to the area function, if it were just equal to that part, then this graph would be the graph of f, but it would also be the graph of g prime because of the first fundamental theorem of calculus. So this 2x adds a little complicating bit to it, but it's not too bad. All right, let's start with part A. They want g of 0 and g of -5. They want two g values. So I'm going to have to plug in, for the first one, I'm going to have to plug in 0 for that x and also 0 in for that x. So one of them is easy. 2 times 0 is 0. This one is an area that I'm going to have to find to find g of 0, I need to find the area from -2 to 0. And that happens to be this green region right here. So without a symbolic definition of the function, I'm left with finding that area using any kind of geometry formulas that I happen to know. It is an area of a region that is going from left to right as far as the x is concerned. And it's above the x-axis, so this region will be positive. It's a trapezoid. I use the formula for a trapezoid. I get the area for g of 0. G of 5 is a little bit trickier. I have to, don't forget, take -5 and plug it in for x there. So I'm already starting at -10. And now I need the integral from -2 to -5. So that's one thing that's weird about this is I'm going from -2 to -5 that way. So I'm integrating from right to left. That's in the negative direction. All of my delta x's will be negative in this case. What does that do? Well, this part of the region that's above the x-axis, that's actually negative area because I'm integrating from right to left. This area underneath the axis, which would normally be negative area if I were integrating from left to right, is now positive area because I'm integrating from right to left, from -2 to -5. That is that way. So everything that was positive is now negative area-wise, and every region's area that was positive is negative. Okay, so anyway, let's look at their answers for this. There's my work for the trapezoid, average of the base times the height. And here's my work for, I guess, a couple of rectangles. Yeah. So, and again, you have to add -10 to that work in order to get the right answer for g of -5. Okay, now comes a derivative question. Find g prime of x in terms of this function right here. So what do I need to do? I need to find the derivative of this. Let's take the derivative of both sides of this equation. That's g prime of x, and this is 2 plus, what's the derivative of that? Well, this far along in the course, you should recognize that. That's the fundamental theorem of calculus, one of them. I wrote it right here. Remember, the derivative of an area function is equal to that integrand right there with that expression plugged in, f of x. If this is an expression that is more than just x, I would also have to multiply this result by the derivative of that bound, but the derivative of x is just 1. So, fundamental theorem of calculus. Where does that fit in? I want the derivative of g, so that's the derivative of this plus the derivative of that. So the derivative of this thing is just f of x. Notice the lower bound is immaterial. It doesn't matter. You get the same derivative either way. So the answer is 2 plus f of x for g prime. G double prime is just the derivative of that, so it's 0 plus f prime of x. And now I'm ready to answer the questions. What's g double prime of 4? Well, it's f prime of 4. 1, 2, 3, 4. F prime of 4. How do I find f prime? This is f. I got to find the slope. So I find the slope of the graph of f at 4. And then all I got to do is find the slope of the graph at -2. And uh-oh, that's a problem. This is a sharp corner, so I can't find the slope there. There's all kinds of lines that cross that point at different slopes and only touch the graph once. So what do we say with that? We say the slope doesn't exist. This derivative, the second derivative at -2, does not exist. Okay, part C. On what intervals is the graph of g concave down? Well, again, I'm looking for where the second derivative is negative. That will tell me when the graph of the function is concave down, when its second derivative is negative. And how can I tell with the graph of f when the second derivative of g is concave down? Well, the second derivative of g is negative. When is the second derivative of g negative? Well, it's negative when f prime of x is negative. When is f prime of x negative? When this graph has a negative slope. So, positive slope, negative slope here. Positive slope, negative slope there. So those are the two intervals. We want x intervals where the graph of g is concave down. Again, the reasoning, where is g double prime negative? Well, g double prime equals f prime, so the question is where is f prime negative? And f prime will be negative when its graph has a negative slope. There are the answers, by the way. Okay, last question is not all that difficult. They define another function. Now this one is defined in terms of g. This is another function, h. Don't forget, g is in terms of f, so this is h that's in terms of g, and g which is in terms of f. Okay, we'll see where all this shakes out. I want the derivative of this function h at 1, so I have to find a way to take the derivative of that. Well, this looks like the chain rule. I've got an outside function, g, and I've got an inside function. So, peeling the onion, the derivative of h is g prime of whatever this is, times the derivative of that, the inside. Let's look at their answer. H prime is g prime times the inside, g prime of the inside, times the derivative of the inside. Now I want h prime of 1, so I plug 1 in for each x, and I get g prime of 2 times 3. Ooh, what's g prime of 2? Well, remember, I have a formula for g prime of anything. So g prime of 2 is 2 plus f of 2. And what's f of 2? It's 3. So, that's how they got that and that number right there. There's our answer. Okay, that was H4. One thing to take away from this, D was probably not the hardest part of this problem. So, and in fact, you didn't need, well, you needed part B in order to do part D, but you didn't at all need part A or part C to do part D. So, if you don't get a part of a multiple choice question, keep at it. You might be able to get one of the later parts. Thanks.